This is the ninth video and second video on problems on stress strain. In this video, the formulas used are stress is equal to sigma is equal to P upon A is equal to modulus of elasticity into strain. For the strain, the formula used is delta L upon L, or it is equal to sigma divided by E. Formula used for modulus of elasticity, E is equal to stress upon strain, or E is equal to P into L divided by bracket open A into delta L bracket close, or E is equal to sigma into L divided by delta L. Formula used for change in length delta L is equal to P into L divided by bracket open A into E bracket close, or delta L is equal to sigma into L divided by E, or delta L is equal to strain into length. Formula used for force P is equal to sigma into A, and for area A is equal to P divided by sigma. Formulas used for area. Area for solid bar or wire of circular cross section, formula is pi divided by 4 into diameter square. For hollow bar or wire, it is pi by 4 into bracket open capital D square minus small d square bracket close, where capital D is outside diameter, small d is inner diameter. Area for solid rectangle is equal to B into D. Area for hollow rectangle is equal to bracket open capital B into capital D bracket close minus small b into small d bracket close. Area for uniform equilateral triangle is equal to under root 3 divided by 4 into side square. Now let us come to a problem. A load of 4 kN has to be raised at the end of a steel wire if the stress in the wire must not exceed 80 Newton per mm square tensile. Find the extension of 3.5 meter length of wire. Also find the diameter of wire. Take E is equal to 2 into 10 raised to 5 Newton per mm square. Now what is asked is extension of wire, that means delta L, and we have given the sigma. So let us use the formula which is having sigma in the formula. So extension of wire delta L is equal to sigma into L divided by E. This is the formula which we are going to use. Now substitute a value. Sigma given is 80. So here 80 into, now the length is 3.5 meter. Convert it into mm. So it will be 3.5 into 10 raised to 3. Put the bracket in the numerator, then divided by E, 2 into 10 raised to 5, 2 into 10 raised to 5. Put the bracket for the denominator also. And if you are with your calculators, start pressing the buttons here. Bracket open, 80 into 3.5. Then here press the button exponential and then press 3 bracket close divided by 2 into, again here press exponential 5 bracket close is equal to. Check, are you getting the answer? Delta L is equal to 1.4 mm. And now the stress given is tensile, so there will be increase in the length of the bar. So we write in the bracket increases. If you have not got answer, here I am giving the buttons to be pressed on the calculator. So these are the buttons to be pressed. And start from here, bracket open, 80 into 3.5. There is one exponential button on your calculator. Then press 3 bracket close divided by bracket open 2 exponential 5 bracket close is equal to. Press the button very correctly, slowly, one by one. You will see that you get the answer 1.4, and it is now in mm because we have substituted the length in mm. Then we want to find out the diameter. So what is the formula? Stress is equal to P upon A, or when we want the A diameter, for diameter we will use A is equal to P divided by sigma. We can directly write in the exam this formula. If you cannot write it directly, first write sigma is equal to P upon A, then write A is equal to P divided by sigma. Now for the A, substitute the value pi by 4 d square because we want the diameter of the wire. So pi by 4 d square is equal to, this will be the area, P given is 4 kilo Newton, convert it into Newton, so it will become 4000. Stress is 80, so 4000 divided by 80. Now I want d square, so if I take this pi on this side, it will become into pi, and from here 4, if it is taken on the right side, then here it is in the denominator, it will be into 4. So if I write d square is equal to, then it will be d square is equal to 4000 divided by 80 into 4 divided by pi. Now we don't want to increase the steps. Most of the time we want only 3 steps. First step is formula, second step is substitute the value, and in the third step you must get the answer. So how to do it? Now start from here. In your calculator, 4000 divided by 80, then this 4 when it comes here, it will become into 4. So into 4, pi when you take it on this side, it will become divided by, so press divided by, then shift pi. So then press is equal to, so what the answer you are getting now is d square. On your calculator, whatever answer you are getting is d square, but we want d, so press under root answer is equal to, you will get this value, d is equal to 7.98 mm. Here I am giving the buttons on the calculator for d. If you haven't got the answer, press it again. 4000 divided by 80 into 4 divided by shift pi. In your calculator you don't have the direct pi, you have to press the button shift, then pi is equal to, when you press this button is equal to, the answer which you are getting on your calculator is d square. You want d, so what you have to do is press this root, then answer, and then is equal to, you will get the answer 7.98 mm. Make a practice of using the calculator properly, otherwise what happens is you write the formula properly, you substitute the values properly, but your answer is wrong. And don't increase the steps. The more the steps, the more the mistakes. If you have not got the answer, slowly press these buttons once again and make practice of pressing the buttons properly and get the answer. Let us move on to next question. Now in few calculators, students will not have this button exponential, which I am saying here. Instead of that, they have the button into 10 raised to x. Now this exponential button is at the bottom near the answer button. So few calculators will have exponential button and few calculators may have this button into 10 raised to x. So if you have this button into 10 raised to x, remember it, whenever I say press exponential, you have to press this button. A steel rod 10 meter long used in a control mechanism must transmit a tensile force of 6 kN without stretching it more than 0.36 mm nor exceeding an allowable stress of 150 megapascal. What should be the diameter of the rod? Take E is equal to 2 into 10 raised to 5 megapascal. Now megapascal means 1 megapascal is 1 Newton per mm square. Now here delta L is given and we want a diameter of the rod. How we will do it? So now the formula we are going to use is for the extension of the wire, delta L is equal to PL divided by AE. Now this A, I bring it here and delta L I take it here. So A, when I take it on the right side, it will come at the top, and delta L will become divided by when it comes on the right side. So the formula I rewrite it as A is equal to P into L divided by bracket open delta L into E bracket close. Now for A we substitute it as pi by 4 d square is equal to, substitute the value of P. P given is 6 kilonewton. Convert it into Newton, so it will become 6 into 10 raised to 3. Length of the rod is 10 meter. Convert it into mm, so it will become 10 into 10 raised to 3 divided by delta L, that is the extension given is 0.36, so 0.36 mm, substitute here. E is 2 into 10 raised to 5, substitute the value here, 2 into 10 raised to 5, put the bracket in the top here and again put the bracket here in the denominator. Always put the bracket at the top and the bottom, numerator and the denominator, so that your answer doesn't go wrong. Now here I am explaining you how we directly calculated D. Start from here, take the calculators in your hand and start pressing the button. First press the button, bracket open, 6 exponential 3 into 10 exponential 3 bracket close divided by bracket open 0.36 into 2 exponential 5 bracket close is equal to. Now when you press the button is equal to, what you are getting on your calculator is the area, this figure. Okay, now when I take 4 on this side, it will become into 4, and when I take pi on this side, it will become divided by pi. So now what you have to do is press into 4 shift divided by shift pi into 4 divided by shift pi, then press equal to. Now what you are getting on your calculator is d square, the value of d square. You want d, so what you have to do, under root answer is equal to, that will give you the answer. D is equal to 32.57 mm. Again here I am giving you the buttons to be pressed on the calculator once again. If you have not got answer, press the buttons from here, start from here, bracket open 6 exponential 3 into 10 exponential 3 bracket close divided by bracket open 0.36 into 2 exponential 5 bracket close is equal to. So now when you have pressed is equal to, we have completed here to here. So what I am getting on my calculator is area. So what I have to do, 4 when it comes on this side, it is into, pi when it comes on this side, it is divided by. So press into 4 divided by shift pi is equal to. Now these two figures you have taken on this side, so what remains is d square. So what answer you are getting on your calculator is d square, but now you want d. So how to get d? Press root answer is equal to. Try it out. Are you getting the answer? 32.57 mm. If you have not got the answer, press the buttons very slowly and press correctly. You have to press each and every button very correctly in this order. Then in one step you get the answer. Initially you may find it difficult, but make a practice, because in the exam you have limited time and this problem you must finish it within 15 minutes. So, and in the exam you have to write only whatever I am showing in the black. All these things are for your information, which you don't have to write. Again, I'm telling you the thing: if you don't have the exponential button as exp, then you have to press the button into 10 raised to x. Few calculators have this button and few calculators have this button. Now let us come to the next problem. A bar of uniform equilateral triangular section has side of 20 mm. It is 2 meter long and carries an axial push of 30 kN. Find the contraction of bar if E is equal to 200 GPa. Now we have to calculate delta L. But now the section is not circular or rectangular, it is equilateral triangular section. How we do it? We use the simple formula delta L is equal to PL upon AE to calculate the contraction of the bar delta L. Now substitute the value of P. P given is 30 kilonewton, so it will be 30 into 10 raised to 3 in Newton. Length given is 2 meter, so it will be in mm 2 into 10 raised to 3 divided by, now area of equilateral triangular section is root 3 divided by 4 into side square. Side given is 20 square, so root 3 divided by 4 into 20 square, this is the area. And E is 200 GPa, means 2 into 10 raised to 5 Newton per mm square, so substitute here 2 into 10 raised to 5. Put the bracket at the top here, from here to here put one bracket, then again in the denominator from here to here put the second bracket, and then now take the calculators in your hand and I'm teaching you how to press the buttons and what to press. Here bracket open, 30 exponential 3 into 2 exponential 3 bracket close divided by bracket open root 3 divided by 4 into 20, then press the button x square into 2 exponential 5 bracket close is equal to, check, are you getting the answer? 1.732 mm. Now it's a push, so there will be decrease in length, so it decreases. Here the area of uniform equilateral triangular section is equal to root 3 divided by 4 into side square. You must know the formula here for the area, then only you can solve the problem correctly. If you have not got the answer, here I am giving the once again the buttons to be pressed on the calculator. If try it out once again, make a practice of calculator very well. So this is from here, bracket open 30 exponential 3 into 2 exponential 3 bracket close divided by bracket open root 3 divided by 4 into 20 x square into 2 exponential 5 bracket close is equal to, the answer is 1.732 mm. A short hollow cast iron column has a wall thickness of 12 mm. It has to carry a compressive load of 120 kN. Calculate outside diameter D in mm if the allowable working stress in compression is 80 Newton per mm square. Here stress sigma is equal to P divided by A. Area will be A is equal to P divided by sigma. Let us first calculate the area. Substitute the value of stress. Stress is 120 kilonewton, so 120 into 3, and the stress is 80, so divided by 80, it will give you the area 1500 mm square. Now the section is hollow, so this is a section I'm showing, hollow cross section. Now let the inside diameter be small d, outside diameter capital D, thickness is T, the thickness I'm showing here T. So capital D is equal to small d plus 2t. If I write it as small d is equal to, it will become equal to d minus 2t. So if the inner diameter is small d and outer diameter is capital D, then small d is equal to capital D minus 2 into, now the thickness is 12, so 2 into 12, that is 24. Now the formula for area, A is equal to pi divided by 4 bracket open capital D square minus small d square bracket close is equal to pi divided by 4 bracket open capital D square minus, now here I substitute small d as capital D minus 24, so capital D minus 24, and it is square, so put it in bracket and full bracket square, and now again complete this second bracket here. So again area is equal to pi divided by 4 bracket open capital D square. Now I am expanding this bracket D minus 24 bracket square, it will become D square 48D and 24 square. This sign is minus here, so here it will become minus, this will become minus minus plus 24 plus 48D, and this will be minus 24D square. Now this d square and minus d square, they get cancelled, so what remains is pi divided by 4 into bracket open 48d minus 24 square bracket close, and substitute the value of area here, that is 1500, so here it is 1500. Now this 4, when I take it here on this left side, it will become into 4. This pi, when I take it on this left side, it will become divided by pi. So it will become 1500 into 4 divided by pi. This is plus 24d square. If I take it on this side, it will become plus 24d square is equal to 48d. Now how to calculate d? Take the calculator in your hand and start from here, and remember that here you have to put one bracket. If you don't put this bracket, your answer may go wrong, and if you forget to put the bracket, then when you reach the pi, press equal to. So let us start from here, bracket open 1500 into 4 divided by shift pi bracket close plus 24 square is equal to, now what you are getting on your calculator is 48d. So after pressing the button is equal to, press divided by 48 is equal to, you will get this answer 51.788 mm. Here I am giving the buttons for the calculator. If you don't put the bracket, what you have to do is you have to do it like this, 1500 into 4 divided by shift pi, then press is equal to, then plus 24 x square is equal to divided by 48 is equal to, you get the answer. Or you can press it like this, bracket open 1500 into 4 divided by shift pi bracket close plus 24 x square is equal to divided by 48 is equal to, and you get this answer directly. You don't have to increase too many steps because it takes a lot of time, and sometimes when you increase the steps you make mistakes. The more the steps, the more the mistakes. Here I am giving one assignment. Assignment number 3. Question number 1. A brass rod 1.5 meter long and 20 mm diameter was found to deform by 1.9 mm under tensile load of 40 kN. Calculate modulus of elasticity. The answer is modulus of elasticity is equal to 100.5189 Newton per mm square. Try it. Question number 2. A hollow cast iron column has internal diameter 200 mm. What should be the external diameter of column so that it could carry a load of 1600 kN without exceeding the stress 90 megapascal? The answer is D is equal to 250.27 mm. Question number 3. A mild steel flat 75 mm wide and 150 mm thickness and 1.5 meter long is subjected to pull of 45 kilonewton. If the elongation of the flat is 0.64 mm, find Young's modulus. The answer here is E is equal to 9.375 into 10 raised to 3 Newton per mm square. Question number 4. A string 4 mm in diameter has original length 2 meter. The string is pulled by a force of 200 kilonewton. If the final length of the spring is 2.002 mm, determine stress, strain, Young's modulus. The answer is stress is equal to 15.915 into 10 raised to 3 Newton per mm square. Strain is equal to 0.001. Young's modulus is equal to 15.915 into 10 raised to 6 Newton per mm square. Now in this problem, delta L is not given. So this is the final length, that is 2.002, and original length is 2 meter. So delta L is equal to final length minus original length, that is 2.002 minus 2. That will give you the change in length delta L. And delta L upon original length L will give you strain. Strain is 0.001, and here there is no unit because strain doesn't have any unit. Be a master. Thank you.